All right, good morning. Welcome back to trigonometry here. We have a couple of problems. This is problem 1A, 1B, and 1C. We got a couple of triangles, and what's going to happen here is the instructions are to come up with all six trigonometric functions for this triangle for angle A. Okay, so the first thing we got to do with this one is we got to say, hey, what's going on with this? Let me pause you, put up a calculator to help me get the values here. So we're going to go ahead and pause for a moment. All right, so the first thing we have to do with this triangle is I'd like to know what all three of the sides are. Okay, so here we have to figure out, we have a hypotenuse, we have an A and a B. So we have A squared plus B squared is equal to C squared. I usually set my A for the adjacent side, it doesn't matter, and my C to be the hypotenuse, that one does matter. So we'll go ahead and sort this out. So we've got the adjacent side, which I don't know what it is, that's my question mark, plus B squared, that's the square root of 5 squared is equal to 2 square roots of 3 squared. Okay, so we're trying to figure out what this last remaining side is. So I have a squared plus square root of 5 squared is just going to be 5 is equal to. Now, you can use the calculator for this. That's fine. I was going to, but this one, it's like 2 squared is going to be 4, and the square root of 3 squared is going to be 3. So we're going to say this is equal to 12. Okay, so my a squared is equal to 12 minus 5. A squared would then be 7. That means a is equal to the square root of 7. So we're going to go ahead and replace this question mark with the square root of 7. All right, that's our first little thing here. Next, we have to get all six trigonometric functions here. So we're going to say this is the sine of A, and that's going to be the opposite over hypotenuse. So we're going to go, and you can write down the SOHCAHTOA thing like on your test somewhere. That's fine. If that's the way you remember it, then that's the way it goes. But the opposite is going to be the square root of 5 divided by my hypotenuse, which is 2 root 3. Okay, we'll fix this up in a moment. Cosine is going to be the square root of 7 over the hypotenuse, which is going to be 2 root 3. And then we finally have the tangent, which is going to be square root of 5 over square root of 7. So tangent of A, adjacent over opposite over adjacent, is equal to the square root of 5 divided by the square root of 7. All right. I'm going to make some room here. I should have made this a little bit better as far as adjusting my room, but we'll go ahead and do this. Okay. So we can go ahead and make some space here for my cosecant of A is equal to 2 root 3 divided by the square root of 5. It's just the reciprocal of the sine. Secant of A is equal to 2 root 3 over the square root of 7. Okay. And finally, the cotangent of A is equal to the square root of 7 over the square root of 5. All right. So the important things that I'm looking for is, did you get all six of these things? Did you get the definitions correctly? And does each of these functions have an argument? Okay, because when you go off to calculus one, if you do, um, your calculus teachers get enraged if, well, they take a lot of points off if you don't have the sign of A. If you just have sine, S-I-N, they think you're making some kind of religious discussion. That's not what you're trying to do. It's a sine, not a sin. Okay, so be careful about that. The last thing we have to do is we have to rationalize our denominators. So I'm going to multiply square root of 3 by square root of 3 on this one. So square root of 5 times square root of 3, that's going to be the square root of 15. You don't have to simplify. It's fine. And we have 2 times 3, which is going to give me 6. Okay, here we're going to say we have square root of 3 over square root of 3. That's going to be the square root of 21. Square root of 3 times square root of 3 is 3. 3 times 2 again is 6. All right. And then for this piece here, we have 7 over square root of 7. We have the square root of 5 times 7 is 35. Square root of 7 times square root of 7 is just 7. Okay, and we're going to do the same thing on this side. Okay, so we have the square root of 35 over 35, or over square root of 5 times 20. Square root of 5 is going to be 25. Okay, we have square root of 7 here. Square root of 7. So we have 2 root 21. Again, you don't have to simplify. It'd be nice if you do, but you don't have to. Divided by 7. And then we have the square root of 5 here, square root of 5 here. So we have 2 square root of 15. Okay, all divided by 5 times 5 is going to be 5. Okay, so that is going to be our problem here for this, and that's what we would go ahead and deal with. Okay, so that's the first problem. Okay, second problem. It's a different triangle with a slightly different configuration, right? We still have to identify the hypotenuse. We have our a squared plus b squared is equal to c squared. So here we have the adjacent side is 4 square roots of 6, and we have to square this. Plus b squared is equal to c squared, which is 14 squared. Well, that's 296. You're allowed to use your calculators. I'm not taking them away from you. And we have 4 times the square root of 6 squared. That's going to be 16 times 6. That's going to be 96. Okay, so we have 96 plus b squared is equal to 296. And if you wanted to plug it in a calculator, I don't have a problem with that. We can say, what is 4 times the square root of 6? Say equals, and then we'll go ahead and square it, make sure we get the right answer here. But we look at that, it's 96. All right, so we have our b squared is equal to 296 minus 96. We have 200. So b is equal to the square root of 200. Okay, we're going to go ahead and change our little question mark to the square root of 200. There we go. All right, now we have to do the same thing. So we're going to say the opposite of a. So we have, again, we're going to check this thing out. So we have sine, cosine, and tangent. There you go. Tangent of A. We have the cosecant of A, secant of A, cotangent of A, and we'll go ahead and sort that out. So the sine of A is a square root of 200 divided by 14. Okay, square root of 200 divided by 14. The important thing here is figuring out which one is the hypotenuse, and it's always the side that is opposite the angle. Okay, that's how we're going to do that. Okay, so the cosine is the adjacent. That's 4 square roots of 6. 4 root 6 divided by the square root of 200. And tangent is finally opposite over adjacent. So we have the square root of 200 over 4 root 6. Okay, so we have the square root of 200 over 4 root 6. Okay, secant or cosecant, secant, and cotangent, they are simply reciprocals. We have 14 over the square root of 200. We have the square root of 200. I'm sorry, I messed that one up. That's not the same thing. Okay, because I have to flip it. Okay, so we have 14 over the square root of 200. That's a little bit better. Okay, here we have 200 over 4 root 16, or 4 root 6, not 16, just 6. Okay. All right, 4 root 6. There we go. Okay. And then finally, cotangent is going to be 4 root 6 over the square root of 200. All right. And now we have to go through and rationalize denominators. Okay. This one's already done because 14 is a rational number. We don't have to worry about that. Now we have to figure out what's going on here, square root of 200. So we could say that this is going to be 4, and we have 6 times 200. So 2 times 6 is going to be the square root of 1,200. Again, you don't have to reduce or anything like that, but that's 12,000. I went 1,200. There we go. 1,200, and then divided by 200 times 200 is going to, square root of 200 times square root of 200 is going to be 200. We could reduce this further, but you're not required to reduce for this thing. For this piece, I'm just going to get rid of the 6's here. So we have 6 times 200, which again is going to be 1,200 under a square root. And then we have 4 times 6, which is going to give me 24. Okay. On the other piece, here we have the square root of 200, square root of 200. So we have 6 times 200. That's going to be 4 root 1,200 divided by 200. Again, we could do some stuff here. Okay. Square root of 6 over square root of 6. We have square root of 1,200. It's all under the square root. 4 times square root of 6 times square root of 6. We have 6 times 4. It's 24. And then we could go up to the first piece and we could say, okay, we need square root of 200 over square root of 200. So we have 14 square roots of 200 divided by 200. And that would be our answer. I don't need to know the numerical approximations for any of these numbers, 4 decimals if you really insist because you like closure, but you're okay to leave these as ratios and just leave them be. Again, make sure that each of your trigonometric functions has an argument. That's one of the things I look for. Make sure your denominators are rationalized. You don't have to reduce, but just make sure you have all six of them. And again, if your first move here is to write down SOHCAHTOA, okay, I'm going to feel a little sad because you haven't practiced enough, but I'm not going to take you off any points. I'm not going to penalize you in any kind of a way for having to write that down to remember what your trigonometric relationships are. Okay, I would hope that you would know them by now, but that's we're going to both have to live with that at this point. Okay, next problem. It's kind of a triangle in a similar operation. Again, we have that 4 roots of 6 with the square root of 50. Let's see what happens. So we have our a squared plus b squared is equal to c squared. So we can say we have a squared plus 4 root 6 squared is equal to the square root of 50 squared. All right, so we have a squared plus, let's go ahead and sort this out. So let's see, that's going to be square root of 6 squared is going to be 6. 6 times 16 is going to be 96 is equal to, this is wrong because that should be the highest one. We can't get negative numbers. All right, so I'm going to have to fix this problem for you guys. This one is not correct. Is this 500? We'll have to check. Okay, so we're going to double check this one. For now, this problem is not correct. Please ignore this problem. Okay, we'll go ahead and we'll sort that out. But we're going to call it here. And I'm sorry for giving you guys the wrong problem on that one. The one in your exam is actually the correct one, but this one is, because I've done it, but that one is not going to work out. So thank you very much for watching the video. I'm going to see you in the next video, and we'll stop us there, and we'll see you in the next video. Take care.